Let's keep doing the first problem from the 2008 Calculus BC exam. We're on part B. Part B. I think that's too thick. Okay, it says the horizontal line y equals -2 splits the region R, this is R, into two parts. Write but do not evaluate an integral expression for the area of the part of R that is below the horizontal line. So let's draw y is equal to -2. So y equals -2 would look like this. Y is just a constant. That's not thick enough. I don't know if you can see that. Let me do it as a thick line. And in a darker color maybe. See, y is equal to -2 will look something like that. And what they're saying is that it splits this region R into two parts, right? This part and this part. And what they want to know is an integral expression for the area of the part of R that is below the horizontal line. So they care about the area of this part of R. And remember, they just want us to write the expression, not evaluate it. So that'll hopefully save us time. So how do we figure this out? Well, the easy part is actually to figure out what the expression we're going to take the definite integral of, and it's going to be a little bit harder to figure out the boundary points. So what is the expression within the definite integral that we'll use? Well, just like we did in part A, think about we're going to take a sum of a bunch of rectangles, and the height of the rectangles is going to be the difference between the two functions, right? And this is y is equal to -2. And then this function right here is y is equal to, and we had written it down in part 3, but that's x cubed minus 4x. That's this curve right here. So the height of each of these little rectangles is going to be -2 minus x to the third minus 4x. That's the height of each of these rectangles. And then the width of each of those rectangles, we know from, well, just learning calculus or learning integrals, the width is dx. So we're going to multiply that times dx. And then we're going to take all of the sums from x is equal to whatever this point is to whatever this point is. So we need to figure out this point, this value of x, which is going to be here, and then this value of x, which is going to be there. And so these are really just two of the points where these two functions intersect each other. So how do we figure out those points? What we could do is we can set them equal to each other. So we could say at what x values does x to the third minus 4x equal -2, right? At what x values are the y values the same? Right? So we just set them equal to each other, and let's see, if we wanted to write this as a proper polynomial expression, we would get x to the third minus 4x plus 2 is equal to 0. And I actually just tried to record a video where I was doing this on the fly, and I kept staring at this, and I was like, boy, this is a hard polynomial to factor. I kept trying to guess numbers or figuring out. I even tried to do Newton's method, and I kept getting weird numbers, and I became suspicious of myself. And then I looked at the actual test. Actually, I could show it to you. And it says right there, a graphing calculator is required for some problems or parts of problems. And I realized that they probably want us to use a graphing calculator to figure out the roots of this polynomial. So let's do that. It's been a long time since I actually took AP Calculus, and now I remember that a graphing calculator was a big deal. So let's use this. I just actually downloaded this TI-85 emulator. So let's use this to figure out the roots of this polynomial. So let's turn it on. And let's see. If we want to figure out the roots, we use the poly function. So second poly. What's the order of this polynomial? It's a third degree polynomial, right? It has an x to the third. So order is 3. Enter. And what are the coefficients? Well, the coefficient on the x to the third term is 1. Go down. What's the coefficient on the x squared term? Well, there is no x squared term, right? So that coefficient is 0. Go down. What's the coefficient on the x term? It's -4, right? So -4. Go down again. And then the coefficient, or the constant term, Well, that's just going to be 2. And now we can just hit solve. Let's see. And we get 3 crazy numbers, and this shows you that this would have been very hard to solve analytically using, if you have a normal brain. So let's see. There are 3 places where y equals negative 2 intersects y is equal to x to the third minus 4x. It intersects at minus 2.21, but that's off of this graph. That's